Hello everyone and welcome to Mark Scheme Merchant. This video will cover chlorofluorocarbons and the ozone layer. Okay, let's dive into the topic. The ozone layer is a layer of the stratosphere that contains a high concentration of ozone. Ozone absorbs harmful UV rays. Here's the equation that shows how the ozone layer is maintained. Ozone absorbs UV light and splits into an oxygen molecule and an oxygen radical. But oxygen can also be reformed like I've shown here. As you can see, this is a reversible reaction, so as well as being broken down, ozone can be reformed. Chlorofluorocarbons, or CFCs, are haloalkanes that only contain carbon, fluorine and chlorine, so all of the hydrogens have been replaced. Here are some of the properties of CFCs. They are non-toxic, volatile and overall very stable molecules. These were widely used in fridges and as aerosol propellants until it became known that CFCs have ozone depleting properties. Let's take a look at how CFCs affect the ozone layer. When chlorofluorocarbons make their way up into the stratosphere, they absorb UV light and the weaker carbon-halogen bond breaks, forming two radicals. We're going to use CF2Cl2, also known as Freon 12, as our chlorofluorocarbon for this example. The carbon-chlorine bond will break under UV light, and we form a Cl radical and a CF2Cl radical. Either one can react with ozone, but we'll use the Cl radical to make our lives easier. The chlorine radical reacts with ozone and takes an oxygen from ozone, leaving us with ClO radical and an oxygen molecule. That ClO radical can either react with an oxygen atom or ozone to form a Cl radical and oxygen molecule. The regeneration of that Cl radical means two things. One, it's a catalyst, so we can call this a catalytic breakdown of ozone, and two, the radical can continue to destroy ozone molecules in a chain reaction. One chlorine radical can destroy about 10,000 ozone molecules before it's removed and forms a stable compound. The overall equation after removing our spectators looks like this. Here's what it looks like using the oxygen atom. And here's what it looks like using ozone. For the OCR spec, you also need to know about how nitrogen oxides can destroy ozone. NO radicals can form from nitrogen oxides and then react with ozone in the same way as a chlorine radical would. Here's what that looks like. And here's the overall equation. Finally, alternatives to CFCs. All you really need to know for this is that HCFCs, hydrochlorofluorocarbons, and HFCs, hydrofluorocarbons, exist as temporary alternatives. They break down much faster than CFCs, but still damage the ozone layer, and they are greenhouse gases, so they contribute to the greenhouse effect. And that's all there is to it. Hopefully this video was helpful. If it was, give it a like, consider subscribing so you don't miss any upcoming videos, and send this video to your peers to help them out.